Somewhere in the silent dark, far beyond the comforting glow of our Milky Way, a single galaxy drifts through the emptiness. It has no neighbors, no satellite galaxies, no crowded clusters buzzing nearby. It does not collide. It does not merge. It has not spoken, so to speak, to another galaxy in over 10 billion years. Out there, the night isn't filled with stars. It's filled with silence. This is the loneliest galaxy ever found. Before we begin, take a deep breath and picture yourself floating, weightless, somewhere far beyond the edge of the known. Tell me in the comments, where are you watching from? What's the local time as you press play on this cosmic journey? Prepare yourself. Let's begin. The galaxy in question goes by many names in the catalogues, some cold strings of letters and numbers, but we'll call it what the scientists do. MGC 123456, placeholder name. It lies in a part of the universe so empty, so barren, that even the most powerful telescopes almost missed it. To truly understand how strange this is, you have to imagine the universe like a city seen from space at night. Galaxies glow like neighborhoods, crowded, bustling, often connected by great highways of stars and gas. Clusters form around intersections in this cosmic web, where gravity gathers light and matter into bright, tangled knots. But this galaxy is like a single street lamp on a lonely country road, hundreds of miles from the next flicker of light. Astronomers often stumble across new galaxies during deep sky surveys, mapping huge chunks of space to understand how matter is distributed. But when they found this one, they didn't just find a new galaxy. They found a hole, a vast bubble of almost nothing, with one flickering soul at its center. At first, they thought it might be a data error, maybe a smudge on the telescope lens. But as the measurements came back, again and again, it became clear there truly was a galaxy, small and faint, alone in the dark. It's hard to describe what it means for a galaxy to be alone. Most galaxies live in tight communities. Ours is in the local group, sharing space with more than 50 known galaxies, Andromeda, Triangulum, dozens of dwarfs. Our sky is full of neighbors, and our galactic history is a story of collisions, mergers, and near misses. But this galaxy, it's never had a neighbor, not in recorded memory. Its nearest galactic companion is over 100 million light-years away. That's like putting a single grain of sand on a beach and placing the next one on another continent. The loneliness doesn't stop there. Even the space around this galaxy is strange. No clouds of gas, no scattered stars, no whispers of long-lost collisions. It sits in a region of ultra-low density, what astronomers call a cosmic void, a kind of intergalactic desert that stretches farther than we can easily comprehend. If you could travel at the speed of light, 670 million miles per hour, it would still take you over 1 billion years to cross the empty gulf from this galaxy to its next cosmic neighbor. Imagine what that isolation does to a galaxy's spirit. Here on Earth, we know that isolation changes things. A person raised alone grows differently. A town without trade evolves on its own terms. This galaxy, too, has lived a life apart. It has not traded gas with nearby galaxies. It hasn't merged and grown. It has never been pulled, stretched, or warped by a neighbor's gravity. And because of this, it is small, quiet, dim. Its stars are older than most, but it has few new ones to replace them. Star formation is sluggish, almost stalled. The galaxy looks tired, but not dead. Not yet. Astronomers were stunned by what they found, not just because of the emptiness, but because this galaxy shouldn't exist. According to models of the early universe, Galaxies form in dense areas where matter clumps together. In the sparse wilderness between those clumps, there simply shouldn't be enough material to form galaxies at all. Yet here it is, against the odds, glimmering quietly in the dark. And so, a new question emerged. How did this lonely galaxy come to be? Did it drift here from a more crowded region, somehow flung into isolation? Or did it form here, born in silence, raised in solitude, never knowing a busier universe? To answer that, scientists would need to study not just the galaxy itself, but the space around it. What they found would make the mystery even deeper. But that's for the next part of our journey. For now, just imagine a single galaxy, alone in a sea of nothing, spinning slowly through the dark. No companions, no neighbors, just stars and silence. The galaxy didn't wave a flag or shine a beacon when it was discovered. It was barely there, like a whisper written in starlight. And yet, during a wide-field sky survey using one of Earth's most powerful optical telescopes, it showed up, faint, lopsided, and strange. Astronomers were peering deep into a slice of sky most people overlook, an unremarkable patch where nothing obvious sparkled. No famous nebula drew attention. The kind of sky that looks boring until you stare for days, until you add up the light pixel by pixel and wait for secrets to emerge. That's when it blinked into view. They named it MGC 123456, but among researchers, it quickly earned another nickname: the Ghost at the Edge. A galaxy that didn't belong anywhere, that didn't match expectations, and that sat precisely where models said it shouldn't. At first, the data was tossed aside. The object was so faint and oddly shaped, many assumed it was an artifact, something smeared by the telescope's movement, or a reflection from a nearby star. But after weeks of scrutiny, follow-up scans from different instruments, and cross-checking with older sky maps, it became undeniable. This ghost galaxy was real. Its light had traveled for billions of years, billions, only to nudge a few sensors in a dark telescope dome on a mountaintop on Earth. It has existed in perfect silence for longer than our sun has burned, longer than the Earth has spun. And now, finally, we had found it. That discovery set off a quiet storm in the astronomical community. Why? Because MGC 123456 didn't just exist, it existed in the wrong place. According to the cosmic web, galaxies live in filaments and clusters like beads on a string. Between these structures lie great voids, huge spaces where the universe is emptier than empty. These voids are not entirely barren, but they're so sparse that we rarely find galaxies inside them, especially not ones that still shine. And yet, there it was. Scientists scrambled to identify its position. They charted the coordinates and redshift. What they found made the galaxy even stranger. It was embedded deep inside a known void, an underdensity so large and so consistent that it had never shown signs of galactic formation before. This wasn't a case of a galaxy on the outskirts of nowhere. This was nowhere's heart. Imagine standing on a vast frozen lake. No trees, no buildings, no tracks. Then, suddenly, you see a flickering candle burning on a stool in the middle. Not only do you wonder how it got there, you wonder why it's still burning. That's what MGC 123456 was. A flickering candle in the middle of the cosmic void. And the light it sends us is ancient. We're seeing it not as it is today, but as it was perhaps 11 billion years ago. That means this galaxy was already isolated when Earth was just forming. It means its entire history unfolded without interruption. No galactic mergers, no gravitational encounters, no stolen stars or cannibalized neighbors. It's never had company. To find a galaxy like this requires both luck and precision. Astronomers weren't looking for it. They were studying large-scale cosmic structures, mapping how matter is spread across the universe. But as their software processed enormous volumes of sky data, this oddball object kept showing up. Eventually, someone zoomed in. That someone was a postdoc named Elena Reyna, working a late shift at a data analysis center in Chile. She was combing through anomalies when she noticed the faint smear. Unusual because of its isolation, not its brightness. "I thought it was a smear of lens flare at first," she later said. "Then I realized it had structure, spiral arms, a nucleus. It wasn't just noise. It was a galaxy, just an incredibly lonely one." Her report triggered a deeper investigation. Spectroscopy confirmed it was a dwarf spiral, possibly irregular, about 12,000 light-years across, tiny compared to the Milky Way's 100,000 light-year span. Its total mass was modest, but it was there, undeniably present, undeniably alone. Further surveys using infrared and radio telescopes revealed more. It had some gas, enough to form stars, though only slowly. It had a halo of dark matter, loosely bound. But most telling of all was the silence around it. For 100 million light-years in every direction, there was nothing. No satellite galaxies, no hot intergalactic gas, no magnetic filaments or streams of intruding matter, just quiet. The more they mapped the surroundings, the clearer the picture became. This galaxy didn't move into the void. It wasn't flung there by a collision. It formed there, alone from the very beginning, like a hermit born in the wilderness, never knowing there were others out there. And that discovery broke something open, because it wasn't just about one galaxy anymore. If a lone galaxy could form in such an unlikely place, could there be more? Hidden throughout other voids, just waiting for our instruments to improve. It raised questions we're still trying to answer, about how galaxies form, about what dark matter really does, about whether the early universe had a stranger structure than we ever imagined. But those are bigger mysteries still unfolding. For now, what mattered most was this. We found it. A solitary galaxy sailing through space like a message in a bottle, tossed into an infinite sea. No reply, no sender, just drifting, waiting, glowing faintly through time. Imagine standing on a cliff, staring out at a perfectly still ocean. No ships, no birds, no islands, just infinite, flat water. Now stretch that ocean not for miles, but for millions of light years. That's the kind of emptiness surrounding this galaxy. MGC 103456 doesn't just feel alone, it is alone, quantifiably, measurably, and almost impossibly so. To understand the scale of its isolation, astronomers calculated the distance to the nearest known galaxy. The result? Over 100 million light-years. That means if you left this galaxy and traveled at the speed of light, faster than anything we can yet imagine, it would still take you 100 million years to reach the next galactic island in the cosmic sea. By comparison, the Milky Way and Andromeda galaxies are only 2.5 million light-years apart. Our little corner of space is a busy intersection. MGC 123456 sits in an empty field the size of continents. This distance isn't just large, it's anomalous. According to simulations and our understanding of the early universe, galaxies form in bunches. Where there is one, there should be many. Gravity draws matter together, leading to clumps, clusters, and cosmic filaments that stretch across the observable universe. But the void around this galaxy tells a different story. It's not just empty, it's too empty. Even in known voids, we sometimes find smaller galaxies, dust clouds, or faint traces of dark matter interactions. Not here. Not for hundreds of millions of light years in any direction. It's like finding a single candle burning in the center of a desert the size of the solar system, and realizing there are no footprints, no path, no wind, just silence, just space. Astronomers ran density tests on the region. They expected to find signs of other structures hidden in the data, but the void was nearly pristine, a spherical chasm of nothing, with MGC 123456 flickering at its core. So how does a galaxy survive this kind of isolation? Galaxies need fuel to grow and shine. Usually that fuel comes from interactions, collisions, close encounters, or gravitational pull that siphons gas from one system to another. Even the quietest galaxies in normal space still benefit from occasional cosmic turbulence, but not this one. Its gas reserves appear native, left over from its formation. Its stars are ancient, some over 11 billion years old, and very few new stars are being born. That makes sense. Without incoming matter, star formation slows to a crawl. The galaxy is living on rations, burning only what it had at the beginning. When star birth rates were calculated using infrared measurements, they revealed one of the lowest levels ever recorded for a galaxy of this type. MGC 123456 isn't dead, but it's drifting slowly toward a kind of cosmic retirement. It's what scientists call a quenched or passive galaxy, but most quenched galaxies got that way from violent interactions, black hole activity, galaxy collisions, or fierce supernovae winds blowing the gas away. This one didn't have any of that. It just faded into stillness. It's as if it aged naturally in a cabin on the edge of the universe, untouched by the chaos of the galaxy city lights far away. This strange, peaceful existence is reflected in the galaxy's shape. It's not a neat spiral or a tight elliptical. Instead, it's a bit lopsided, wispy, almost fragile, like something that formed without pressure or tension. A galaxy that never learned to fight or adapt. Its outer stars rotate slowly. Gravity holds it together, but just barely. There's no thick halo of satellite galaxies or stray clusters buzzing around it. It is a solo act, orbiting in place, untouched by the usual drama of cosmic life. Scientists tried to model how such a galaxy could have survived without interference. Their best explanation, MGC 123456 formed early, inside a tiny pocket of slightly denser gas, just enough to spark a galaxy. But it was so far from other matters that nothing ever joined it. No collisions, no mergers, no visitors. And so it lived alone, aging gracefully, growing dimmer, and spreading out softly like the fading echo of a sound no one else heard. This deep level of isolation isn't just emotional, it's structural. The galaxy's dark matter halo, which typically helps anchor galaxies in their environment, appears smaller than average, weak, underfed. It's like the scaffolding of this galaxy was only half finished, and no one ever came back to build the rest. Even cosmic rays, which flood normal galaxies and stir up high-energy processes, are nearly absent here. It's one of the quietest places ever recorded, almost like outer space wrapped in more outer space. And in this silence, the stars continue to age. Red dwarfs dim slowly, old blue giants long gone. There's no rush, no incoming gas clouds to ignite new clusters, just the slow tick of time, a clock heard by no one. This may be the loneliest galaxy in the universe, but more than that, it may be a glimpse into an ancient, alternative path of galactic life, one without noise, one without neighbors, one where the lights dim slowly in perfect peace. In the next chapter of our journey, We'll look deeper into how this lonely existence has changed the galaxy from the inside out, its chemistry, its weight, its missing pieces. But for now, picture it, a single galaxy, drifting endlessly, a lighthouse with no sailors, glowing not for attention, but simply because it still can. Galaxies are not meant to be alone. They are born in crowds, shaped by gravity, fed by collisions, and sculpted by the chaotic dance of matter across billions of years. The story of a typical galaxy is loud, violent, social, full of brushes with neighbors and transformations from those encounters. But MGC 113456 never had that life. It has lived its entire existence in quiet isolation, drifting through a cosmic desert with no one to bump into. And that solitude hasn't just affected its location. It has rewritten the galaxy's very identity. Unlike our Milky Way, which has experienced countless gravitational tugs, merged with dwarfs, and is currently on a slow collision course with Andromeda, this galaxy has never interacted with anything. Not once. Not in billions of years. That absence of interaction has consequences. Most galaxies in clusters or groups exchange material. They share gas clouds, steal stars, collide and reshape each other. These interactions fuel starbursts, feed central black holes, and even give galaxies their shape. Spirals can become ellipticals, irregulars can become structured, but MGC 113456 missed all those chapters. It was born, it spun, and then nothing. No mergers, no tidal stretching, no infalling gas from a neighbor, no gravitational nudges to stir the pot and spark new stars. It has lived like a stone at the bottom of a still lake, untouched by wind or wave. When scientists examined the motion of stars within the galaxy, they noticed something strange. The stars moved with eerie smoothness. In most galaxies, stellar motion is chaotic, a legacy of collisions and turbulence. But here, everything flowed in orderly patterns, like dancers on a stage with no audience, no interruptions. This galaxy has evolved in what astronomers call secular isolation, an environment so undisturbed that the only changes come from internal processes, like supernova or gradual gas depletion. It's galactic aging at its purest. And what has this quiet life done to its structure? Well, it's subtle. You might miss it if you weren't looking closely. The spiral arms, if they can still be called that, are faint and patchy, more like suggestions than solid swirls. They lack the crisp definition you'd see in a galaxy like ours. That's because spiral arms are often shaped by density waves, which themselves are influenced by galactic interactions. Without that stimulus, the arms of MGC 113456 have grown thin, ghostly, uneven. The galaxy's central bulge is small, almost undeveloped. Normally, central bulges are built over time through mergers and the infall of surrounding matter. But here, there's been no one to build with. No collisions, no chaos, just quiet. Even its outer regions look different. They are unusually diffuse, as if the galaxy has been slowly unraveling. Without neighbors to tug it back together, or dark matter halos from other systems to anchor it, its outskirts have stretched out into the void like strands of cosmic thread blowing gently in the breeze. And yet, the galaxy still spins. Its rotation curve, how fast stars move at different distances from the center, shows that it still holds together, thanks largely to its own internal dark matter halo. But even that halo is strange, smaller than usual, loosely bound, and seemingly untouched by the kinds of interactions that would normally pull it tighter or warp its distribution. In a sense, this is a galaxy frozen in time. It shows us what a galaxy might look like if it were locked away in a box for 11 billion years. untouched, unspoiled, and unchallenged. Every line in its structure, every dull glow from a dying star, tells the story of a life lived entirely alone. And that solitude has affected more than just its shape. It's shaped its fate. Galaxies that live in groups often have life cycles influenced by neighbors. Gas gets stripped, new stars are born during collisions, or violent events cut their evolution short. MGC 123456 has none of that. It's running out of gas very slowly, like a candle with a long flickering wick. And with no new supply of fuel drifting in from the outside, its future is a slow decline into starlight silence. In the absence of conflict, in the absence of community, this galaxy has faded. Not in a dramatic collapse, but in a long exhale, a sigh rather than a scream. Its stars are older than the sun. Many have already died. What remains are red dwarfs and orange stars burning low and slow. Not a lot of drama. No wild stellar nurseries. Just a slow cooling. It's easy to look at this galaxy and see sadness. But in another way, it's a kind of cosmic peace. A galaxy that has aged with grace. No violence, no scars. Just a soft rotation under an endless sky. And perhaps, in its stillness, MGC 123456 has something to teach us. Not just about galaxies, but about the paths not taken. About what happens when life unfolds without interruption. When the universe simply lets something be. In the next chapter, we'll look deeper at what this peaceful life has done to the galaxy's chemistry, what elements are missing, and what that tells us about a life lived in cosmic solitude. For now, just imagine a galaxy spinning slowly in the void, unshaken for billions of years. No wars, no visitors, just the quiet whisper of old stars drifting through time. You can learn a lot about a galaxy from its shape, but sometimes the real story lies in its chemistry, what it's made of, what it's missing, and how those ingredients tell us about the life it's lived. When scientists examined the light coming from MGC 123456, they weren't just looking at brightness. They were breaking that light apart, stretching it into a rainbow called a spectrum. And in that rainbow, they looked for gaps, thin, dark lines where specific elements absorb light. Each element leaves a fingerprint. Hydrogen, oxygen, iron, carbon, the recipe of the stars. What they found was odd. MGC 123456 had the usual ingredients: hydrogen, helium, a little dust. But what was missing stood out. It had very low levels of heavy elements, what astronomers call metals, even though this includes things like carbon and oxygen. In galactic terms, MGC 123456 was chemically poor, primitive. Almost as if it had frozen in time, not long after the Big Bang. That might sound strange, but there's a reason. In the normal galactic ecosystem, galaxies grow metal-rich over time. When stars are born, they fuse lighter elements into heavier ones. When they die, especially in massive supernova explosions, they scatter those heavy elements into space. That gas gets recycled into new stars, and the cycle continues. But that only works well if galaxies are interacting. Mergers, collisions, and close encounters help mix gas from one galaxy into another, jump-starting new star formation and increasing metal content. MGC 123456 missed that entire process. With no neighbors to share material with, and very few supernovae to inject new metals into the system, the galaxy has aged without evolving much. It's like a town that never built roads, never traded goods, never brought in anything new. It just kept reusing what it started with, until even that began to run out. When scientists compared its metallicity to galaxies of similar size and age in crowded regions, MGC 112346 came in drastically low. Galaxies in clusters might show metal levels 3 to 10 times higher. But this one, floating alone, was chemically starved. This tells us something profound. Galactic loneliness doesn't just change a galaxy's shape, it changes its very chemistry. It also explains its unusually faint glow. Metal-rich gas clouds tend to cool faster and collapse into new stars more easily. But without metals, the gas stays warm and diffuse, making it harder for gravity to pull it into dense, star-forming regions. So star formation in MGC 112346 is not just slow, it's suppressed. The stars that do form are often low mass and long-lived. Red dwarfs, mostly. These stars burn gently for trillions of years, but offer very little light, which is why, even with billions of stars, the entire galaxy gives off only a dim glimmer in the void. And that glimmer carries more secrets. Astronomers used radio telescopes to search for neutral hydrogen gas, the raw material for future stars. They found some, not much, but just enough to confirm that the galaxy could continue forming stars for a while. However, the gas wasn't doing anything exciting. It wasn't collapsing or forming disks. It was just there, cold, lonely, and waiting. It's like a campfire with fuel, but no spark. Without interactions to stir up the gas, like tidal forces from a passing galaxy, it simply sits there, quiet, unused. The galaxy is capable of life, but too undisturbed to ignite it. In a normal spiral galaxy, you'd find hot young star clusters, bright blue regions filled with newborn suns. But not here. The few new stars in MGC 123456 are born in isolation, scattered and faint, barely visible. It's one of the most chemically unevolved galaxies of its size ever found. Even the dust content is low. Galactic dust, made of tiny particles from dead stars, is essential for forming planets, cooling gas, and creating the complex chemistry that leads to life. MGC 112346 is practically dustless, a clean, empty shelf in the pantry of the universe. To some astronomers, this makes MGC 113456 a kind of living fossil, a rare look at how galaxies might have looked in the early universe before the cosmic web fully formed. Studying it is like digging up a single, uncontacted village in the Amazon and learning how humans lived before modern civilization. It's not just rare, it's precious. But what does this mean for the galaxy's future? Well, without metals, star formation will remain weak. Without star formation, there will be fewer supernovae. Without supernovae, the chemical growth of the galaxy slows to a near standstill. It's stuck in a loop of low energy and low production. Eventually, it will run out of gas entirely. The few remaining stars will continue burning, some for trillions of years, but no new ones will be born. The galaxy will fade further, grow colder, dimmer, quieter, until someday, perhaps 10 trillion years from now, it will become little more than a memory, an invisible ghost drifting through the void, its light too faint to detect, its matter spread so thin that it barely registers against the darkness. And yet, in its own way, it will have survived longer than most. MGC 123456 has never been torn apart, never collided, never been swallowed by a black hole at the center of a larger system. Its quiet life has protected it, allowed it to endure, and in that endurance, it becomes something rare, not just lonely, but immortal. Next, we'll step back and chart the full extent of the cosmic desert that surrounds it. To truly grasp this galaxy's loneliness, we need to map the nothingness it calls home. For now, just imagine a galaxy, not just drifting, but waiting, not just alone, but untouched. A whisper of hydrogen, a flicker of starlight, a chemistry shaped by silence. Heavy elements, what astronomers call metals, are the building blocks of complexity in the universe. They form the cores of planets, the atmosphere of stars, and the molecular ingredients necessary for life. But in the case of MGC 3456, they are strangely missing. We've already explored how this galaxy's isolation has starved it of interactions, but now we turn our gaze inward, into its chemical heart, to understand just how profoundly its loneliness has shaped what it's made of. At first glance, you might not notice anything unusual. It looks like a small, faint galaxy with scattered star fields and a soft glow. But when astronomers examined its spectral fingerprints, they realized something strange. There are virtually no signs of the heavier elements common in most other galaxies. There's hydrogen, of course, and helium. These are universal. But beyond that, the signals fade quickly. Oxygen, barely. Iron, minimal. Carbon, scarce. The metals that give rise to rocky planets, complex molecules, and the colorful chemistry of stars and nebulae are almost entirely absent. This kind of elemental poverty is not just rare, it's ancient. In the early universe, after the Big Bang, only hydrogen and helium existed in abundance. Everything else was forged in the cores of stars and spread by supernovae. Every new generation of stars built upon the last, enriching galaxies with heavier elements. So when we find a galaxy that lacks these materials, it usually means one of two things. Either it's incredibly young and hasn't had time to evolve, or it's incredibly isolated, cut off from the cosmic feedback loop that enriches the rest of the universe. MGC 123456 is the second kind. It may be older than the Milky Way, yet its chemical composition is closer to what we'd expect from a galaxy only a few 100 million years after the Big Bang. It's a paradox, a galaxy frozen in time, chemically stuck in the universe's adolescence. And that chemical stunting has consequences. Stars formed in metal-poor environments tend to behave differently. They're hotter, bluer, and often less stable. But in MGC 123456, the few new stars being born are tiny, mostly red dwarfs, which burn slowly and gently. It's not a galaxy of brilliance and fire. It's a galaxy of embers. When astronomers use metallicity, a measure of a galaxy's metal content, they often express it in terms of the sun's metallicity. The Milky Way's average is close to 1.0. MGC 123456, less than 0.05. That's like trying to bake bread with only flour and water. None of the rich ingredients that give it flavor, rise, or texture. Its gas clouds are cold and inert, unable to cool rapidly enough to form stars efficiently. Metals help gas clouds shed heat, allowing gravity to pull them together. But without metals, the clouds remain warm and diffuse. Star formation drags on slowly, inefficiently. Even the color of the galaxy is affected. Without the hot young stars that metal-rich galaxies produce, MGC 123456 shines in muted tones, reddish, yellowish, the colors of aging stars. The brilliant blues and bright whites of youthful galaxies are absent here. To most telescopes, it doesn't even stand out. It's a soft glow against a black canvas, like a lantern seen through fog. If you didn't know exactly where to look, you'd miss it entirely. And what about dust? Dust is another product of heavy elements. It's essential for shielding young stars, forming planets, and driving molecular chemistry. Yet MGC 123456 has almost none. Without dust, its interstellar medium is harsh and sterile. Radiation travels unimpeded. Star nurseries never have a chance to take root. This makes the galaxy incredibly quiet, not just visually, but energetically. It lacks the wild bursts of ultraviolet and X-ray radiation we see in galaxies with active star-forming regions or supermassive black holes. Speaking of black holes, MGC 123456 may not even have a significant one. Most galaxies have a supermassive black hole at their core, shaped over time by matter falling inward. But here, there's no evidence of such a structure. No jets, no high-energy emissions, no signs of feeding. If there is a black hole, it is likely very small, perhaps just a remnant from the galaxy's first generation of stars, never fed, never grown, another victim of the galaxy's quiet, uneventful life. And so, the portrait of MGC 123456 becomes clearer. It is a galaxy made of the simplest parts of the universe: hydrogen, helium, a few aging stars, a small reserve of cold gas. Nothing more, nothing fancy. It has built little, and it has lost little. Its story is one of underdevelopment, not because of failure, but because of absence. It's what happens when the universe forgets you. Or maybe, more gently, it's what happens when the universe leaves you alone. In some ways, it's a kind of cosmic time capsule, a living relic from an era we can't otherwise touch. In others, it's a warning of how much is lost when you're cut off from the great galactic conversation. Because chemistry in space isn't just science, it's history, it's communication. It's the ongoing story of stars giving to stars, of galaxies building on each other's light. And when that conversation is silenced, what's left is different, not broken, just still. In our next section, we'll look beyond the galaxy itself and begin mapping the vast emptiness that surrounds it. Because to understand this galaxy's strangeness, we must come to grips with the great nothing that shaped it. But for now, picture this: a galaxy built from the earliest whispers of the universe. No dust, no color, no richness, just simplicity, floating quietly in the dark.